So I have some terms I'd like to explain to you guys. One of them is called the molecular formula. One of them is called the molecular formula. The other one is called the empirical formula. So the molecular formula is how it is, okay? This is water, this is glucose, this is ozone, this is N2H4, whatever the name of that compound is. This is the way it is. This is the actual formula. Okay, this is called the molecular formula. Okay, the empirical formula, what do you think the empirical formula is? Okay, simplify. Okay, simplify means most reduced. Okay, how do we reduce C6H12O6? Bless you. How can we reduce this? Divide by 6? Divide by 6 is correct. Okay, so this is the most reduced. Okay, can you reduce H2O? Can you reduce a 2 and a 1? You cannot. So the molecular formula is the same. So they can be the same. Or if you want to reduce it, you can reduce it. So O3, they divided it by 3. You guys see that? N2H4, what did they do here? They divided it by 2. So we have the most reduced. If you can't reduce it, you can't reduce it. You cannot. If you can reduce it, go ahead and reduce it. This is called the empirical formula. So if I take this CH2O, let's say I multiply this by 2. Okay, you can do that. You can do that. If I take the CH2O and multiply it by 2, what will be my new formula? Right. Okay. So I can do that. I can multiply it, and this is some other name. I do not know the name. Okay, if I take this empirical formula and multiply it by 3, what's my new empirical formula? It's 3H6O3. Okay, like that, I have another formula. I do not know the name of that one. Okay, so just realize most reduced is empirical, but we could multiply it by some number, some math, and then get the molecular formula. All right, now let's talk about nomenclature. This is the last part of the chapter, then we'll have our test review. So, guys, remember group 1, 1A, what charge will there be? Okay, so this is a good multiple choice test question. Okay, +1. What's the name of this? Okay, what about group 2? And what charge would they like to be? Okay, so again, another good test question for next Thursday. Okay, what would group 7A be? Halogens. And what charge would they like to be? -1. Okay. And then group 6, 6A, group 16 or 6A. They don't have a name, but what charge would they like to be? -2. Okay, and these are noble gases. So this would be on the exam in terms of like a multiple choice or something. Okay, and we know group 18 are the noble gases. Ionic compounds. Okay, metal plus non-metal. Okay, we're going to do something called switcheroo. We're going to switch the numbers. Switcheroo. This is for ionic. Okay, ionic. So we'll take the charge. We'll take the number. We will take the number and switch it. Okay. And this is a metal with a non-metal. Metal with a non-metal. Okay. So do you guys know this? Okay, how will we name Al2O3? What would the name be? Aluminum? Aluminum oxygen? Oxide, okay. What is aluminum oxide made of? Okay, just remember Al is +3. I do not know if it's in your flashcards, but Al is going to be +3. What is oxide ion? -2. So the 3, not the +3, the 3 goes. The 2 goes. Okay, that is switcheroo. Okay, so are we going to write this on the exam? Okay, I'm glad somebody yelled no. You can yell it louder. Okay, yell it louder so that the whole office, the whole building can hear. Okay, I see this. Okay, we see this. Okay, it's just the number. Okay, it's just the number. Okay, it's just the number. So, yes, aluminum oxide will be Al2O3. How about this one here? CaBr2. What would that? Oh, is this ionic or covalent? Oh. Is it ionic or covalent? Ionic. Okay, it's ionic. It's a metal with a non-metal. Calcium. What would this be called? Calcium. Br is bromine. So calcium bromide. Calcium bromide. Okay. Calcium bromide. What is it made of? Calcium is +2. Br is a halogen. It's automatically -1. Okay, it's the 2 that goes here. It's the 2, not the +2. It's the 1 that goes here. This is calcium bromide. All right, how about this one? Na2CO3. What do you guys think? Sodium carbonate. Okay, remember from our flashcards, this is sodium carbonate. Okay, how can we break this down? Sodium is group, I don't have my periodic table, group 1. So because it's group 1, it becomes Na+. And what is CO3? Okay, remember this from our flashcards? Yes? Okay, so you can bring your flashcards to the test, but bring that to the test. So this 2 goes here, the 1 goes there, and it's Na2CO3. This is called carbonate. Okay, bring your flashcards to the exam, but this is called carbonate ion, carbonate. All right, let's name some compounds here. For transition metals, okay, what will we need to do? Anything that you guys remember from transition metals? Okay, we're going to put the Roman numerals. Okay, put the charge as Roman numerals. The charge as Roman numerals. I have my periodic table, so any element you see here inside this red square, okay, inside this red square, okay, it gets Roman numerals. Fe+2, Fe+3, vanadium +5, vanadium +3, chromium +2, chromium +3. They can take all sorts of different charges, okay, different charges, yeah. All right, let's go ahead and name some of these compounds. By the way, before we name these compounds, there's also something called covalent compounds. Okay, what are covalent compounds? This is sharing. Okay, we share electrons. Sharing. Okay, what is ionic? It's not sharing. What is it? Giving and taking. Very good. Giving and taking. So sharing electrons. So we're looking here at two nonmetals. Nonmetal to nonmetal. Okay, how will we name these? Okay, we will name these with prefixes. Okay, prefixes. Okay, can anyone tell me the prefixes here? Yeah, very good. So what's one? Mono. What's two? Okay, what's three? Four? Tetra. Though quad is a good one. I like it. Quad. It's not quad, it's tetra. Five? Penta. Six? Seven? I've heard septa, but I think, yeah, hepta. We'll go with hepta. Eight? The octagon. Eight? Octa. Nine? And I think we'll go up to 10, deca. Okay, so what would SF6 be? First of all, is it covalent or ionic? S is sulfur. F is fluorine. Fluorine, just know, is a halogen. So is this ionic or covalent? And how would we name this? That's hexa, right. This is, we don't say mono. We don't use mono here, but we'll just go with sulfur. Hexafluorine, no. Hexafluoride, right? So on the exam, make sure you know ionic versus covalent, and make sure you know your prefixes. Okay. How about is this ionic or covalent? We have nitrogen, which is non-metallic. It's in, that side of the periodic table. Okay, if it's to this side of the staircase, it's a nonmetal. We have nitrogen, and we have oxygen. Oxygen is also a nonmetal, so it's covalent. This would be, what would this be? What's two? So it's going to be dinitrogen. Five is pentaoxide. Okay, dinitrogen pentaoxide. And I think you guys mentioned it. I think it was you, Samantha. It was you. Okay, don't forget, if it's transition metals, you're going to put Roman numerals. Okay, these are for ionic compounds. Okay, make sure you know that. All right, let's do some of these problems here. All right, who wants to tackle this one here? Is this ionic or covalent? CuNO3, the NO3 is twice. Ionic, good, Emily. And how will you name this? What is Cu? Okay, copper. Anything special about copper? Look where it is in the periodic table. Transition metal. So what charge would that be? Yeah, 2. What will we put it as? Roman numerals. And then what is NO3? It's NO3 minus, but what's NO3? 2 goes here. It goes in as 2, and the 1 goes here. NO3 minus is called nitrate. Remember nitrate? So this is called copper 2 nitrate. Okay, that's the answer for this one. It's ionic, as Emily is correct. Yes? All right, how about this one? Is it ionic or covalent? Okay, that K is a metal. The H2PO4 is all nonmetals. What would this be called? Okay, we have K plus. Okay, anybody remember this from their flashcards? Okay, so this is potassium. What's this in our flashcards? Dihydrogen phosphate. Okay, this is just from our flashcards, dihydrogen phosphate. So this is potassium. Should we put Roman numerals in here? No. Okay, no. Right? Because what, David? It's just potassium. What group is potassium in? Group 1. So this is potassium dihydrogen phosphate. NH4ClO3. What do you guys think? Is this ionic or covalent? Okay, this is a tricky one, but you guys are right. Zach, you mentioned ionic? You did? Well, if you did, you're correct. That's ionic. So why is this ionic? What is this made of? Okay, we have NH4 plus. And then what else do we have? ClO3 minus. So what is NH4 plus called? Ammonium ion. And what is ClO3 minus called? Chlorate. Chlorate. Okay, so this is ionic, and the correct name of this compound is ammonium chlorate. So why are we not using prefixes? How come no mono, di, tri, tetra, all of that? These are not covalent compounds. That is the right answer. Yep. That's the right answer. All right, how about mercury 1 nitrite? Okay, so mercury, this is not on the exam, but mercury, it's in your flashcards. Mercury here is going to be Hg2 plus. Okay, I believe that's what it's going to be. It's from your flashcards. Okay, I won't test you on this, but mercury is Hg2 plus. Okay, plus 1 because it's in the transition metal. But what's something I'd like for you guys to know is what is nitrite? Not nitrate, but nitrite. NO2 and what charge? Minus. Okay, minus. Is this ionic or covalent? We have a positive with a negative. We have a metal with a whole bunch of nonmetals. It is ionic. And the formula for this is Hg2NO2. Okay. Oh, yes, sir.
How did you know to put the dihydrogen?
Dihydrogen? Where's the dihydrogen? Oh, the name of this compound is dihydrogen phosphate. Yeah, it is just from our flashcards. Yeah. Just like this is nitrate, NO3 minus. This is nitrite, NO2 minus. This is chlorate, ClO3 minus. This just happens to be called H2PO4 minus. Yes, sir. Did that answer your question?
Yeah.
Yeah. All right, good job, you guys. All right, next one, cesium sulfide. What do you guys think? Ionic is correct. What's the formula for this ionic compound? CS. What will be the charge of CS? I'm looking at my periodic table. I see it's in plus. I see that it's in group 1. And then what is sulfide? Not oxide, but sulfide. S. Sulfide. So what would be sulfide? S minus 2. S minus 2. Everyone can see that? S minus 2. Oxide, sulfide, selenide, fluoride, chloride, bromide, nitride. So is everyone okay that this is S minus 2? Can I get thumbs up? Nobody give me a thumbs up. All right, what's sulfide ion then? Sulfide is S minus 2. Cesium sulfide is CS2S. That is correct. So all of these are ionic compounds. Let's continue onwards here. Okay, how about calcium phosphate? What do you guys think? Okay, what is calcium and what would its charge be? Okay, Ca plus 2, that's correct. And what is phosphate? You guys remember this? Okay, I heard it. I heard one right answer and the right charge. So let's put it together. What will we get? 4 PO4 minus 3. Okay, this is called the phosphate ion. So this is like a grammar. You know, like any introductory class, you have to learn the grammar. So this is our grammar. Okay. All right, is this ionic or covalent? Okay, it's ionic because we have a pluses reacting with the minuses. We have a metal in calcium reacting with a bunch of nonmetals in phosphate. And we will do switcheroo. It's the 2 that goes. But again, this is another mistake I see students make. It's the 2 that goes to the whole thing. Okay, it's the 3 that goes to the whole calcium. So are we going to write this on the exam? Or whatever that means. Okay. Right, Gerardo is correct. We have to put it in parentheses. So this becomes Ca3PO4. That whole thing gets the 2. Okay, this is calcium phosphate. How about SiCl4? So Si is kind of more in non-metallic area. It's more to the left. So it's a non-metal silicon with a non-metal chlorine. So we'll call this covalent. Okay, you see how the silicon is to the left, the chlorine is to the left. So with this being covalent, how would you name this? How would you guys name this? What's Si? Silicon. Silicon chloride? Tetrachloride. Okay, it's silicon tetrachloride. Okay, it's a covalent molecule. How about P4O10? Covalent or ionic? We have phosphorus. Where's phosphorus here? Where's oxygen? We have oxygen here. Okay, so what do you guys think? It's to the left of this staircase. So, covalent. How will we name this? Tetra. What's P? Phosphorus. And then 10. What's 10? Deca. It's oxygen, not chlorine. Oxide. Okay, tetraphorus deca oxide. Okay, you guys getting it? Okay, we've got a couple of more here, so bear with me. Carbon disulfide. What do you guys think? Ionic or covalent? Okay, this is not carbon dioxide where we root it out. This is carbon disulfide. And what's the formula? CS2 is carbon disulfide. All right, 3 more. Disilicon hexabromide, ionic or covalent? The di is 2, hexa is 6. For covalent compounds, nonmetal with nonmetal, we're going to use the prefixes. Okay, this is going to be silicon is Si. What is di? 2, what is bromide? I mean, what is bromine? And what's hexa? So that is Si2, Br2. Okay. All right, so we have a situation here. I'm not going to test you on it, but we have a situation where we have to deal with acids. So acids are their whole different situation. I'm not going to, you do not need to know the theory, but acids give off proton, and proton here is going to be H+. Have you heard of acidic? Have you heard of basic? So acids give off H+. This H+ has many different names. One of the names is called proton. Okay, one of the names is called proton. So acids are going to give off H+ proton. The H is usually in the front. Okay, the H is usually in the front. Okay, so naming acids has its own different complications. But this is how I want you to know for acids. We go 8 goes to ic. Okay, 8 goes to ic. So as an example, we have NO3 minus. Okay, I'm going to add the H+ to it. I'm going to acidify it. Okay, so here we have nitrate. If I acidify this by adding H+, it becomes HNO3. So 8 becomes ic. So nitrate becomes nitric acid. Okay. What about sulfate? Okay, SO4 minus 2. Let's say I acidify it. I add H+. You know, your stomach is acidic. Your gut is acidic, so it has a lot of H+. Okay. What happens if I take sulfate from our acids and then acidify it? I get H2SO4 from switcheroo. Sulfate becomes sulfuric acid. 8 becomes ic. speaking of our gut, which has a lot of H plus in it, the acid that's in our gut is HCl. So if I take chloride and I acidify it, I get HCl. Okay? The H's are in the front. They come off. Okay? This is chloride ion, sulfate ion, nitrate ion. If I acidified chloride ion, I get, again, this is weird, I understand it. This is not my rules, but this is hydrochloric acid. Okay, so what would be R minus B? Hydrobromic acid. Okay. These are acids. All right, let's do one more here. How about phosphate? Okay, phosphate. You guys know this is phosphate. You answered it correctly right here. But I'm going to acidify it. Okay, I'm going to add H plus to it. Okay, when I add H plus to it with the switcheroo, this becomes H3PO4. So phosphate. Okay, ion. Okay, what would be the name if 8 becomes ick? There's no hydro. Okay, that's only for the halogens. Okay, or actually this is yeah, I'll just forget that. Okay, so this would be phosphoric acid, or you can call it phosphoric acid. Okay, at least that's how I learned it. Phosphate becomes phosphoric acid. Okay, but on the exam, this will not be on the exam, but if you see it on the exam, if you put phosphoric acid, I think you're okay. This is technically called phosphoric acid. Okay. All right. All right, we have nitrate here. What was this one? Not nitrate, but nitrite. Okay, I'm going to acidify it. I'm going to add H plus. Okay, if I add H plus with the switcheroo, it becomes HNO2. Okay, this is another rule now I'd like you to know for acids. Ate becomes ick. Ite becomes us. Ite becomes us. Okay, ite becomes us. So what would nitrite, when we acidify it, become as the acid? I think I heard it. Nitrous acid. Nitrous acid. So ate becomes ick, ite becomes us. We have phosphate. How about this one? Okay. What happens if we acidify it? We add protons to it. It becomes H3PO3, and what is the name if ite becomes us? Phosphoric acid and phosphorus acid. Phosphorus acid. Okay, and that's the answer for this one. Okay. So acids, as I mentioned to you before, are just a whole different scheme. Okay, whole different scheme. Okay, what is IO4 minus? What do you guys think? Okay.
Ion.
Well, what's the name of the ion? Okay, I think someone here in our class mentioned that ClO3 minus was chlorate. Okay, IO3 minus would be iodate. Okay, ClO4 minus, what would that be? Okay, this would be perchlorate. Okay, what would IO4 minus be? Oops, sorry. Okay. So this is the periodate ion. Periodate. What happens if I acidify this? What happens if I add an H plus to this and get HiO4? What would be the name of this acid? Okay, so iodate, iodic acid. Periodic acid. Periodic acid, that's right. You got me. If I were to take ClO3 minus and acidify it and becomes HClO3, what would be the name of this acid be called? Chlorate. If I add a proton to it, what will it be? Chloric acid. Okay, chloric acid. So that is how we do acids. Okay, it's a little bit of a different scheme here. Okay. David, just remember, coming back to your question here, I was just reminded, chloride, hydrochloric acid, bromide, hydrobromic acid, fluoride, hydrofluoric acid, okay? So the hydro comes when you're dealing with just these individual ions, okay?
Oh, is it just with fluoride or bromide, or is it everything that ends with IDE?
It would be things that end in IDE, yeah. So this is the cyanide ion. So this is cyanide. So if I were to acidify it, I would get hydrocyanic acid, yes. So just for your future reference. That's a good question, because when to put the hydro in is something that's a little confusing, but as Gerardo said, our classmate, you can put the hydro in. 8, you can put the ic in. Ite, you put the us in. Okay. It takes some practice getting used to, but at least you guys have that preliminary exposure. All right. so you can look at this. This is just some other material to help you study. This has to do with the acids, and then this is just a naming scheme, okay, between ionic and covalent. So do read this, and you can get a better understanding of how to name these. So that wraps up chapter 2. That will wrap up everything that's on the test. And let's just take the rest of the class period to review what's on this exam. Okay. I'll lecture for about another 20 to 25 minutes. So this test will cover chapters 1 and 2, and it's going to be next Tuesday. Turn in your quiz also next Thursday. Okay, next Thursday, and turn in your quiz also next Thursday. Okay. So there's some questions here on nomenclature, which we went over some nomenclature problems. So there's about 7 to 8 of these. Okay, so. Whether it's ionic, whether it's covalent, okay? So let's do a couple more practice ones. Okay, what do you think this would be? Ionic. And how would you name this? Iron 2, what else? What is this ion called? Hydroxide, okay? Yeah. So like this, there'll be like 6 or 7 of these, okay? How about something that's very easy? Carbon dioxide. So about 7 to 8 of these. How about this one here? Iron 2 hydroxide. How about iron 3 perchlorate? How will you write the formula for that? Okay, iron is going to be +3. What is perchlorate? ClO4 minus. Okay, so the 3 goes here. The 1 and the minus goes there, so this is what you want to write on your test. Okay, don't forget the parentheses. Okay, don't forget the parentheses, because the ClO4 minus, which is called perchlorate, is the whole thing. So when you do switcheroo, the whole thing gets the 3. The whole thing gets the 3. Yes, sir?
You want to show the work too as well?
Not here. You don't have to show the work. This is not math. So, I mean, if you want to, maybe for partial points, I can see where he or she went wrong, but yeah. So, obviously, the more you show, I can see what's your thought process. So, yeah, you can. Okay, how about this one here? How will you name this compound? And is it ionic or covalent? Okay, this will be ionic. Okay, and how will you name this compound? Okay, what is Cr? Chromium, and it's a transition metal. So what will we have to put as the charge? And what will we put it as? Roman numerals, very good. And what's NO3 minus? Nitrate. Okay, so this would be chromium 3 nitrate. Okay. Do you know how to name some of the covalent ones? Okay, heptasulf. We'll just. Okay, that's fine. Heptasulfur hexaoxide. Okay. Again, for covalent, we're looking for the prefixes. Okay. How about this one here? Xe is xenon. And then what's next? Tetrafluoride. Very good. Okay, xenon tetrafluoride. Right, so like that, you just name them and state whether they're ionic or covalent. All right, any questions on this section of the test? Okay. All right, so like that, 7 or 8 of these.
The last compound, covalent.
This compound is covalent. Xenon is Xe, and it's a noble gas. And F is fluorine, and that is also non-metallic. So non-metal with non-metal is covalent. Yeah, go ahead.
Question is, does noble gas not react with other, like...
This can be made with very high pressure and very high temperature. Yeah, very high pressure, high temperature, non-ideal conditions. So yes, you can get that. Go ahead.
Anything with like suffix is it most likely to be covalent?
Sulfates?
No, suffix. Tri, tetra.
Prefix.
Prefix.
Yeah, if it's a prefix, it's covalent. And non-metal with non-metal. Yeah. Okay, except for this one. Okay, these are all non-metals, but are they ionic or covalent? Okay, because anytime you see pluses with minuses, yeah, NH4OH, this is ammonium hydroxide, this is ammonium chlorate. So just remember some of these polyatomic ions, hydroxide, anything that has that charge can be ionic. Magnesium hydroxide, ammonium chlorate. All right, yeah. So these would be NOA ionic, right? You see that? Like these two specifically? Okay, these would be considered ionic. Anything else? All right, so just brush up on your nomenclature. Okay, you guys we did a lab. Didn't we do a lab when did we do that lab? Tuesday. Okay, we went 90 minutes. Right? So you must be tired. And that lab report has a lot of nomenclature on it too, so I think you should be good on this. Protons, neutrons, and electrons. How many protons, how many neutrons, how many electrons? So let me give you some examples here. If I have something that has a mass number 115, and if I have something that has 80 neutrons, and it has 36 electrons. Okay, what is the name of this element? Okay. All right, so the mass number is, what is the mass number? It's the sum of two particles. What are those particles? Okay, this mass number is the sum of protons plus neutrons. Okay, but they gave us the number of neutrons, you see? So to get the number of protons, we will subtract. So what's 115 minus 80? 35. Okay, what element in the periodic table has 35 protons? Bromine. So we got the element, and it has 36 electrons though. So what does that mean?
So on cis minus.
You need to put the minus sign. Okay, so last year, or the night class, the night students, they just put bromine. Is this right, or is this right? Okay, because there's 36 electrons and 35 protons, this is the right answer. Okay, this is not the right answer. What would make this the right answer? 35, 35. Correct. 35, 35 would make it the right answer. How about this one here? How about O minus 2? First of all, what's the name of this? This is oxide. How many protons, neutrons, and electrons? Oh, I'll give you this as 16. There. Okay, how many protons, neutrons, and electrons? 8 protons. And how many electrons? 10 electrons. 10, okay? Right. What element in the periodic table is this isoelectric with? Isoelectric. Neon, okay? What does isoelectric mean? Same number of electrons, actually same electron configuration. What about bromine? Bromine ion. Bromide ion. Bromide ion. Okay, what is this isoelectric with? What other element has the same electron configuration as Br minus? Kr, okay? Anything else maybe? How about Rb plus? How about Sr plus 2? How about Sc minus 2? Okay, all of these have 10 electrons. Okay? And we call that isoelectric. Okay? So O minus 2. How about some other isoelectric species here before we move on? Neon. Can you name me another one? What other element or ion has 10 electrons? O minus 2 has 10, neon has 10, F minus has 10. Anything else? O minus 2. F minus 2, Na plus. Anything else? Magnesium plus 2. Okay, all of these will have how many electrons? 10. Okay, everyone okay with this? All right, so protons, neutrons, and electrons on the exam. Okay. Let me give you another one. Let's look at beryllium. Okay, if beryllium were to form an ion, what would be its charge? +2, looking at the periodic table. So that would be isoelectric with what noble gas? Okay, with which noble gas? Helium. Okay, helium. Helium. Everyone see this? And how many electrons would that be? 2. Okay, 2. All right, let's move on to some of the multiple choice portion of this exam. Okay, so we have some multiple choice here. Actually, before we go to multiple choice, there is one calculation. So let's do that calculation here. So let's say, okay, do you guys, this is chapter 4, okay? But I'm going to test you on it. That's okay. Okay, let's say I have something that's 0.15 molar sodium nitrate. Okay, 0.15 molar. Okay, this molar, though I did not explicitly lecture on it, this chapter 3. Okay, I'll tell you that this molar actually means moles per liter. Okay, it's a concentration. You know what a concentration is. If I add water to something that's concentrated, would it be more concentrated or less concentrated? Less. Okay, it's called dilution. So this has 0.15 moles per liter. So 0.15 molar, big M, is actually the same thing as 0.15 moles of NaNO3 per liter. Okay, this is how much amount in that volume. This is how much amount in that volume. Okay, this is molar. Okay, or you can call it molarity. Okay, you do this all the time in your kitchen. Okay, when you mix, I don't know, cake powder with something, you know, or when you mix vitamin C powder, okay, with water. Okay, you're making something either concentrated or dilute. Okay, so you take this solid, this powder, dump it in water, we get a concentration. This is moles over liter. Okay, so molar is 0.15 moles over liter. I have this bottle. That's 0.15 moles of NaNO3 over liters. Okay, I'm going to take 10 milliliters out of this bottle. Okay, the question here on the test is how many grams did I take out? This is the question. Okay, I take out some volume out of this bottle. How many grams did I take out? Okay, that's the question. Alright, so this is how you'll solve this question. Okay, we take 10 mils out of the bottle. Okay, the first thing is realize that 0.15 molar is the same thing as 0.15 moles of the chemical over liters. Okay, here the chemical is NaNO3. So we're going to take that 10 mils, we're going to convert it to liters because, you know, molarity is moles over liter. Molarity, molar is moles over liter. So it's 1,000 milliliters, 1 liter. Okay. Now we will take this 0.15 moles over liter and put that here. Okay. This is the amount of moles. To get to the amount of grams, what do we need to do? 1 mole of NaNO3 contains how many grams? Do you remember this? What do we have to add up? One mole of NaNO3 is how many grams? Okay, so how much is Na? Okay, we'll go with 23.01. Okay, yours may be a little bit more, a little bit less. That's okay. Okay, grams per mole. Okay, how much is nitrogen? Okay, we'll go at 14.01 grams are in 1 mole. How much is oxygen? 15.999, we'll go with 16.01. Okay, but how many oxygens do I have? So we'll multiply this by 3. Okay. So if we add all this up, 1 mole of NaNO3 is this many grams of NaNO3. Okay. So just add those bottom numbers up to get the molecular weight. 1 mole is that many grams. .05. So 1 mole of NaNO3 has how many grams? So if I were to give you 85.05 grams of NaNO3, how much did I give you? 1 mole. Okay. 1 mole. Okay, if I give you 1 mole of NaNO3, Emily, how many grams of NaNO3 did I give you? 85.05 grams. Okay, this is how it works. Okay, and then we like to cancel out our units here. Mil, liter, moles, moles. So this is how many grams it's going to be. So 10 times 0.15 times 85.05 divided by 1,000. About 0.13 grams. Is that what you guys are getting? Yeah, so 0.13 grams. So there's 0.13 grams in 10 mils of a 0.15 molar concentrated solution of NaNO3. Okay, this is how we do this problem. Okay, you'll do it like that on the test, just with different numbers. Yes, go ahead.
So when we answer this question, do we use two significant figures?
Yeah, 2 or 3 is fine.
Okay.
But don't write all of this. Then I'm forced to mark off points. 0.13, yeah, 0.13 sounds good. 0.13, yeah. But like I said, writing all of this just means you're telling me, oh, I'm going to write everything that's on my calculator and show him. Okay. I'll get him. I'll write all, everything on the screen. So, yeah.
So in the exam or test, do you provide calculator or do you need to put out that calculator?
I think, I don't have enough calculators to provide. I have like 2 or 3, but that's all. Yeah. Bring your calculator. I only have like 2, I think. If it's even in my office. Have you seen my office, how small it is? So it'd be hard to even find one. Okay. All right, let's see if we can squeeze in a couple of more here. Any questions on this? Okay, so make sure you're comfortable with this. Big M means what? Big M means moles over liter. Okay. Okay, how will we calculate 1 mole of NaNO3? What do we need to add? Yes, okay, the atomic weights. Okay. All right, so some multiple choice. Okay, make sure you know what matter is. What is matter? Okay, you're matter, I am matter, the air is matter, the planet is matter. Okay, mass and occupies space. Okay, anything that has mass and occupies space. Okay, accuracy versus precision. Okay, so what is precision? Precision is what? Hitting the same spot, consistency, reproducibility. Okay, what is accuracy? Hitting the mark. Hitting the mark is accuracy. So for that lab, what was doing the beaker and the graduated cylinder, what was accurate for you guys? Okay, making sure you get 10 mils each time. Somebody got 9.9, somebody got 9.8 when they averaged them out. Okay, somebody got 6.7, which means the pipette didn't work, or maybe they didn't know how to pipette. Okay, so yeah. Okay, so accuracy is the target, and what is precision again? You want to be consistent. Okay, so the best is being accurate and precise. Okay, so density. Okay, what type of property is density? Is it an intensive property or an extensive property? And what's the difference? Okay, what is intensive? What is an intensive property? Right.
It does not depend on the quality.
It does not depend on the amount. Okay, so density is a classic example of an intensive property. So whether you have 100 grams of copper or 5 grams of copper, it will have the same density. Yes? Okay, so density is a classic example of an intensive property. Okay, density also varies with your temperature. If you increase the temperature, you change the density of the material. Lower the temperature, you lower the density of that material. Okay, so density is an intensive property. And then sig figs. Okay, so are we good with our sig figs? Okay, how many sig figs would be in this number? Okay, you're right. That would be 6 sig figs. How about this one here? 5 sig figs, okay? So I give you a number, just how many sig figs. Okay. How about this number here? 2. Okay, so no whole numbers, because whole numbers can be ambiguous, just know that. So how do we remove the ambiguity? Okay, we put it in scientific notation. Okay, do you remember this? Scientific notation, but no whole numbers on the test. All right, homogeneous versus heterogeneous solution. Okay, what would be an example of something that's a homogeneous solution? Salt water. What would be an example of something that's heterogeneous? Oil and water, swamp water, muddy water, okay, chicken noodle soup. Okay, these are solutions. So like we said before, group 1 or 1A, what are we looking for the ion? +1. What about group 2 or 2A? Halogens. -1. Okay. How about something like CO3 -2? Okay. This is called carbonate. And did it gain 2 electrons or lose 2 electrons? Okay, it gained 2 electrons. Okay, how about NH4 plus, positive, ammonium ion? It lost 1 electron. Okay, so like that on the exam. Do we know the definition of isotopes? Same element, different neutrons. Okay. So example here, carbon 12, carbon 13. Okay, it's carbon, but it's a different number of neutrons. This carbon is more abundant, but this carbon is 1% found in our planet. So even that 1% has to go into this number. You see, even that 1% of carbon 13 contributes to this 12.0107. Okay, if I were to have a guy who's 8 feet tall, and I want you to convert his height to meters, okay, 1 meter is 3.28 feet. Okay, can you guys do that? Feet to meters. Guy is 8 feet tall. Okay, how many meters is he? Okay, this is how you'll do that. You have 8 feet times we know that 1 meter is how many feet? Yeah, so that is the feet cancel, and this will give us his height in meters. Okay, so this will be given. Okay, conversions, basically. These are conversions. Okay, feet to meters.